guys from this year talking about three dimensions automation. So, take it away.
So thanks. So my name is Jussi, and my colleague is Jari. So we are from Digi, and we're going to show you how to do automation properly in a cloud environment. And as the guys in the first session from Huuto mentioned that when moving things to the cloud, you really have to automate everything. So what we're going to show, not only slides but a couple of live demos if the demo gods are with us. So we're going to be using Docker, a Docker orchestration engine called Container, and OpenStack to really provision everything from ground up with a couple of commands. And if the timing works as it did in the afternoon when we tested it, it should take 3.5 minutes to have complete application up and running in the cloud. And as mentioned in the start, we don't have anything. We do have a cloud account somewhere, but that's about it. So I mean, why we are moving things to cloud and why we are talking about things called like DevOps and those sort of things is basically the fact that the world is moving really fast nowadays. We really have to push better software, new services up to the customers really fast and in a continuous manner. So you have to be able to fix things as they break down, because things will break down even now and in the future. If we compare the traditional model and the so-called DevOps model or these sort of continuous delivery and orchestration models, in the traditional world you do things pretty slowly. You set up computers, you set up servers somewhere, you configure them, you install them, and it's, to be honest, it's a really boring job. Nobody really wants to do it anymore. And when things are boring and slow, they tend to be also error prone. So you do when people are doing boring things, they do lots of mistakes, and those mistakes typically cost a lot of money because you break your services and break your revenue chain, and they don't scale. So imagine if you have to provision and configure 1,000 servers. How many people would you have to put to work on that? So you cannot really scale up in the traditional model. What the DevOps world tries to bring into the picture is the sort of a change the artifact so that you don't deploy big things anymore. You deploy smaller changes and you do them more rapidly, which makes you have more predictable results, shorten the lead time to market, and have always things and systems in sync with the desired state. But doing the things is really hard. You have to take into account different things like configuration management. How do you configure and provision your servers? You deploy tools like Puppet or Chef or Ansible, you name it. On top of that, you have to do automation on the deployment. How do you deploy your software then onto the configured servers in the cloud or on premises? The Huuto guys mentioned that they want to scale up the systems when there's peak traffic, for example, in Christmas time. So when you scale up things, how does the new things find each other? How do they discover other services? There are some ways to do this in the cloud that you could take, for example, in the Amazon, you could bake those sort of golden images. So you have always ready-made machine images that you can just drop into place. And the general advice is always you should really treat your servers like a cattle and not pets. So don't give them nice fluffy names on the servers. Otherwise you get attached to them mentally and you don't really want to kill them anymore. So really, what we have to do, or what we want to do, is really automate all these things. So we really want a environment where we can define the infrastructure as a code. But also, I'm looking at the wrong screen and it's on slight delay. We really want to use containers, meaning in this case Docker, to really have our own software, our own applications package, so that we can really just drop them in somewhere and they will run. And of course, nowadays systems are not built in monolithic way, so we will have multiple different containers, so we have to orchestrate them somehow, because they will have interdependencies. Also, another aspect in the automation is the fact that servers need to be updated. There are security breaches like the SSL bugs that were found a few months ago and those sort of things. So you really have to update things. What we want to do is also automate that, so nobody has to sort of keep an eye on the servers in that sense. The servers will update themselves. So we will use a few different tools to automate all these things. So we will use OpenStack tools and Cloud Init technology to really set up the infrastructure for us. We're going to show CoreOS operating system, which is really custom made, or not custom made, but the customized for this sort of operation environment. Docker, as mentioned, as the container tool. And then on top of the stack, we're going to show the orchestration, how to set up the applications then easily. In the demo you're about to see in a few minutes, we're going to actually set up a not so trivial environment anymore. We're going to set up a environment consisting of two different data centers. So we're going to spawn nodes in two different data centers. We're going to actually connect the interweb into it. We're going to slap a private networking across the data centers, and also we're going to create a Docker overlay networking, which makes things really easy to put in the containers. And we are going to actually do that in one command, believe it or not. So Jari, fire away.
Yeah, let's see how this goes. Usually these demos will always work, so let's see. Is the text big enough? Can you see anything? Okay, yeah. So let's get started. First we are going to provision OpenStack infrastructure as seen in the previous slide, and it will spin up networking and security groups and everything for us. It will also spin up virtual machines and install the orchestration part in the nodes. But first we have to create our cluster in our orchestrator, that is container, and we do it like using command line, and let's create this cluster that is called grid, and let's give it the name SaKE demo. And then we are going to get security token from the grid, and we are going to use this token to provision this infrastructure. So I'm going to just replace here the token like this, and then I'm going to give this magical command like a heat stack create that will read our configuration, and it will spawn the infrastructure for us in the OpenStack. And let's see how this goes. Okay, something happened, and now the OpenStack says that SaKE demo cluster is in progress, so it's doing something. And I think we can check the Nova list command that lists all the virtual machines in our account, so that we can see if something is happening there. Yeah, so there is three machines spawning at the moment, and this will bring up our cluster. And in the same time, we can check the actual heat configuration file. That is basically the same as CloudFormation in Amazon. It just tells everything that needs to be done and how it's configured and stuff like that. So it's basically YAML file that has the properties, and it gets the job done. So let's see if we have the infrastructure ready. So at least the heat says and the Nova says that we have the 3 machines running, so it might be working. Let's check from the Docker orchestration side. So yeah, it is also saying that we have these 3 machines now. They're running, and they have the core OS and Docker and container and everything set up, also the overlay networking. So now everything is ready, and we can. So we have this ready, and we can go forward.
Yeah. I guess there's no big question marks at the moment. So what we ended up doing is with one description file and with one command, we created a pretty nice, cool setup between 2 different data centers. And of course, in reality, this could be even 2 different cloud providers. The DC1 could be actually Amazon, and the DC2 could be Azure. And we've actually tested that sort of a setup also. So that's no problem for this system. Of course, the platform itself doesn't bring any value to anybody. So what we want to do is of course, we want to deploy an application or a service into the platform. For this demo, we selected a application called Twissandra, and as the name implies, it's actually a sort of a Twitter clone. Rather simple one, but demonstrates some of the features that they have on Twitter. Also, as the name implies, it uses Cassandra as a backend, and for those for whom Cassandra doesn't mean anything, it's a really nice sort of a NoSQL type of database which you can scale up almost infinitely. I think the biggest Cassandra cluster is about 75,000 nodes in Apple data center somewhere. I'm not sure, but that's what I've read. And to me, 75,000 database nodes in one cluster, that's pretty big. Also, as mentioned, and I guess as all we know, things do break down, even in software. So we actually want to have highly available setup, and as we did have the multiple data centers in use, so why don't span all the application also into the different data centers. So we're going to create 3 different application instances and also 3 different Cassandra instances. And of course, as mentioned, we have to interconnect all these using the Docker overlay networking, so that one node failure doesn't kill the whole system. And of course, we want to do the cluster replication in Cassandra, so that the data is also replicated between nodes and between data centers. What's still missing in the picture is sort of the typical pattern in cloud software, that you don't really expose your application nodes into the interweb, because the interweb is really a bad place and scary place. So you always have to put something in front just to proxy the traffic, and also as a security measure, so that you really make your attack surface as small as possible. So we're gonna slap, surprise, surprise, 3 instances of HA proxy into the front of the application. And also we're gonna cross connect that between the nodes and between the containers. And the HA proxy is actually fully dynamic and self-configuring instance, so that we can actually scale up the Twisandra application. Let's say if we would have more nodes, we would scale it to 100 instances, and the HA proxy could actually figure out the configuration for us. And again, we're gonna do the actual deployment in one command.
Yeah. Let's see how this one goes. So we have our cluster ready here, and we have also like schema for the application. It's I don't know if you know the Docker Compose that describes different services for the Docker. This is something similar for the container. It's just a YAML file that describes different services, and we have here Cassandra, Twisandra, and the load balancers. I'm going to just spin it up, so let's see. Going to check first that nothing is running. Actually in the cluster everything is empty, so I think we can do the deploy command, and let's see what happens. Basically now we just sent the container YAML file to the container master that is the orchestrator of the system, and it is creating now the services and deploying the Docker images and doing all kinds of magical things for us. So let's check the monitor command that shows the actual live state of the cluster. So there we can see the yellow one is the load balancers, and green one is the Cassandra instances, and then there is the Twisandra. And it will take now a couple of minutes because it's downloading those Docker images from the Docker Hub. And actually Cassandra, I think it's something like 600 megabytes, so it will take just a couple of minutes to spin up all of those instances inside our cluster. Meanwhile, we can check a little bit into details what is happening here. So the first service is the Cassandra, and we had defined that we want 3 instances there, and we said that it's stateful application. It has to maintain its state because it's database. We don't want to lose any data. And then we just said that it's using Jussi's fantastic Cassandra image that is working nicely with the overlay network, and we have a couple of environment variables for the Cassandra. And then there is this actual application that is Twisandra, and we said that we also want 3 instances for that because we have a 3-node cluster. So hopefully it will spawn 1 instance per node. And there's also Jussi's Twisandra image and some variables, and we are linking this Twisandra to load balancer, and this makes magic happen here. But let's check first the hooks. Here is some commands that this service will execute when it's starting these instances, and there is actually we are running these commands only on the first instance, and it's executed only once when it's first started, and it's just waiting for the Cassandra cluster to come up, and then it will sync some database migrations and also fill some fake data into the Cassandra. And the last one is the HA proxy or load balancing, and because this Cassandra is linked to it, it will automatically configure it and load balance the traffic from the load balancer to the Cassandra application. And it seems that our cluster is now set up. We have 3 Cassandra instances spread across the cluster, and also Cassandra and load balancing. And let's check the logs first, if this really works or not. I think it might work. So, oh, sorry. Oh, I'm just going to grab IP address of the first node here, so we can test this. I think it's this one. We are going to use a little hack here, but taking this address and let's see. Oh, it opens. So now the request went through the load balancer to the Cassandra application, and the Cassandra application is fetching the data from the Cassandra cluster. And now if we refresh this page, I think it should show that it's coming from the different instances as shown in the top of the page, so it's doing the actual load balancing. So that was that. Any questions?
Yeah, so you can really automate everything when in the cloud environment, and when you do it properly, you really get results that you can you can really have the same results each and every time you do these things. So we've been doing this training and of course putting these things together and tens and tens of times, and we always get the same result.
Yeah.
So that's it.
You mentioned about the Cassandra and adding more nodes, and that it appears you have kind of hard-coded your 3 nodes.
Yeah.
But I guess that leads to service discovery. How we could kind of make it more dynamic.
Yeah, you mean?
For example, at the top of you have Cassandra host 1, 2, and 3. They're in the middle of the screen.
Yeah. In Cassandra world, that actually means that what are the first step seeds, like seed money, sort of. So we could actually use the scale up the instances almost indefinitely, because we would just point the number instances 4 and upwards to the same 3 first initial nodes. And after that, the cluster can configure itself. So we, even though we are spawning the 100 of instances, we still would point that to the first 3 instances to have that as the first point of contact.
So basically, I don't know, we don't have enough memory in our cluster now to spawn the Cassandra instances up, but we can show how to do this with the Cassandra Python app. So basically, it would be something like, let's say 9 instances for the Cassandra application. And now, if we check the state, it will spawn the instances, and all the service discovery and load balancing should just work. There's the 6th instance now, 70 response.
Yeah. And Cassandra would work exactly the same way. although it requires lots and lots of more memory.
Yeah.
Because Cassandra isn't the sort of lowest resource consumption databases that you can have. But it's still quite fantastic piece of software.
I think that deserves a round of applause.
Final question while Ilkka is setting up for the final talk. Okay, thank you very much, guys. Great talk.
No worries. Thanks.
Thank you.
There we go. Hopefully it doesn't sound too bad.
No, that's
Perfect.